Now, as we return to the Los Angeles Sheraton, the Sheraton Los Angeles Airport at 6101 West Central Boulevard, on the 11th floor, that is 1157, and on the amazing 5x12 matrix, and we're using now some of the or the format or of the 3x3 outputs as a support now to design some 3x3 mesh circuit. But we have made the elements relatively simple so that our calculation really comes out easy. In previous example, we have used the actual values of the elements as resistances, but we just set up the format of how the analysis would be done by taking the determinants of the respective components of the circuit. So here we are now, and we are at the point now to find I1, which is Ni1 over delta. So I1, we find now N1 rather, we find N1 first, N11, which is equal now to, replace the voltage value in the first column, so we have now -5, 10 and 0, -4, 8 and 0, 0, 0, 0. That is to find Ni1, the determinant of this matrix. And this is equal now to, we take the determinant of any column, and you get now -5 into 8, 0, 0, 0, plus 10 into -4, 0, 0, 0, and plus 0 into something which would make it 0. And so this determinant will turn out to be now eight times 0 is 0. This would be 0. This would be 0, and that would be 0. Well, according to what we have done here, everything is correct. And so I1 would be equal now to Ni1 over delta. But since the numerator is 0, then I1 will be equal to 0. So we're saying that no current would have come through here. We're going to recheck our calculation because I just made this from my head. I2 will be equals to N I22 over delta. No matter what the value of delta is, we're going to calculate it. This would have, if the numerator is 0, then everything would have been 0. So anyway, Ni2, so we put in the value for, which is -10 and 0. So we have now 6, -4, 0, -10, -5, 10, and 0. I want to find the determinant, and 0, 0, and 5. So that will be 6 into 10, 0, 0, 5, -4 into -5, 5, 0, and 0, plus 0 into something which would make it 0. And so that's equal now to 6 into 50 minus 4 into minus 25. And that's equal now to 300 plus 200 plus 100 rather. That's equal to 400. So we get I22, unlike NI1, to be equal to some value, 400. And therefore, I2 is equal now to NI22, which is 400 over delta. But delta is the determinant of this thing up there. And we could likewise calculate delta. I3 is equal to N I33 over delta, where I3 now, NI3 would be equal to the determinant of replace the voltage value in the last column by, replace the last column by the voltage value. So we get now the determinant of 6 minus 4, 0, minus 4, 8, 0, and minus 5, 10, and 0. This is equal to 6 into eight, 0, 10, 0. This partial will be 0 minus 4 into minus 4, 0, minus 5, 0. So this comes out to be 0 as well. So that I3 is equal to 0 over delta equals 0. So the only place we by way of a current would be in I2, which is 400 over delta. So in this circuit, the current here is 0, the current here is 0, and the current here is NI2 over delta equals 400 over delta. Let's calculate delta for this, and then so we'll actually find the value of the current as 400 over delta. Let's take a break, and then we'll come back and calculate delta.